Hi everyone, this is this week's video and the focus is on problem solving and working through word problem types with your students in a remote learning experience. So I'm sharing out a digital tool from Math Playground. It was shared with me from a colleague and friend, Annalise Record, who was my co-presenter this past summer. We really didn't have a lot of time to focus in on the word problems because we were working on operational understanding and how that's developed, but this is a really valuable resource that I thought would be something good you could use with your class meets for math. You could make a video lesson demonstrating how to use the tool and then ask students to practice going online and doing some word problem types, either in additive thinking or multiplicative thinking. And there's even a really cool fraction tool that you can use as well for grades 4 and 5 who probably were really working in the operations of fractions as we went into a remote learning experience. So just to highlight, in our curriculum maps at all levels, we talk about emphasizing math reasoning through word problem use and the variety of word problem types. This is grade ones, but it's in every single curriculum map at the elementary level. And it's really a good model to use the bar model. I know some people are a little uncomfortable with that. It's not something that they used in their own experience for learning how to solve word problems, but it's really valuable that we develop this understanding at the elementary level because when students are in the middle school, they're going to rely on tape diagrams as one of their reasoning tools for algebraic thinking. So hopefully I will convince you of trying this out either in remote learning or when we're back in our classrooms with our students working through word problem types in a face-to-face small group or whole group situation. So there are actually 24 problem types at the elementary level. So K through 5 have additive problem types: join, add to, take from, part, whole, put together, take part. And then the hardest ones, comparison problems. Comparison with a more situation, comparison with a fewer situation. Then in 3 through 5, we add on multiplication and division. So we add on some more problem types: equal groups, arrays, area, and comparison and multiplicative relationships. The reason there are so many types is because you can solve for solutions, but you can also solve for parts of the problem. So if it's the additive word problem types, you can solve for an add-in or a result. And I've highlighted in yellow showing you where those parts are. And so here are 9, and then here are the other 6 to make 15 different types of additive word problems. And then here are the multiplicative ones. So there are 3 types, and then there are 3 places. We can solve for, again, answers, products or quotients, and then group size, or the size of the group, or number of groups, I'm sorry. Here's the tool that I want to highlight, and it's Thinking Blocks. It's found on Math Playground, and there are 6 different things you can use, and you can link it into Google Classroom. So that's a nice feature. You can just upload it for the week and have kids explore it in a variety of different ways. Thinking Block Juniors is geared towards grades 1 and 2. I don't think I would do this in grade 1 independently, but I do think you could do it to work through some math reasoning with them. And maybe I would hold off until we're back in the classroom, but definitely explore it. And if you think it's a great tool, try it, see how it goes. Thinking Blocks addition would be grades 2 up. Thinking Block multiplication would be grades 3 through 5. Fractions would be grades 3 through 5, although I do think this would be a challenge for grade 3 because you're really just developing the idea of what a unit fraction is and what a fraction is out of a whole. And then for middle school, it's the ratio thinking. And then here's the tool where you can give them a word problem, which I'll show you later, and they can work through the tool and either do a screenshot and send it to you, or they can just use the tool because you asked them to. So let's go into the site. And here we are with Thinking Block Addition. And so I'm going to start with 2 parts, and then you saw how there's more than 2 parts that you can work through. So the good thing about this tool is it does read to them, so you don't have to worry about reading level, and it walks them through the reasoning, not just the calculating part. So that's the hardest part, to get kids to actually reason through problems, not just pick out numbers and just randomly add, subtract, multiply, or divide without making sense of it. So BitBot had some walkie-talkies. He used 11 walkie-talkies in a new project. He gave the remaining 29 walkie-talkies to his neighbor. How many walkie-talkies did BitBot have at first? So we're going to work through our labels. We have his neighbor's walkie-talkies, BitBot's walkie-talkies, and the total. Kids place the labels in, and then they check it right. If they are, it says, okay, start using your bars. So this is the tape diagram part where they're putting their bars in. And now I'm going to put the numbers to the labels. So do we know the total number of walkie-talkies? No. But we know that he used 11 in his new project, and he gave the remaining to his neighbor. So these are BitBots. This is his neighbor, and we're solving for the total. And so hopefully, if we've done some reasoning with bar modeling, if we haven't, then we have to explain to kids that this is an additive relationship. So I'm going to add these two numbers together to find my total here. Here's a situation where I do have regrouping, but it's a fairly easy one. And then I'm given another problem to work through. I want to show you the fraction one because I think this is a really great idea, tool for developing fractional thinking. So I'm going into the find a part. So Dana's riding her bicycle for 12 miles from Some Central to Vertex Valley. She has completed 2/3 of her trip. How many miles did Dana complete? So it's focusing on that we have a whole, and that's the total miles that she's traveled. And the whole would represent one whole bar. And now we're going to break that bar into parts. And so we have to figure out, how many parts do I need? Well, they have to look to the fraction to develop the idea of how many parts. So if she has traveled 2/3, then our trip is broken into 3 equal parts. And you can see, you just slide the slider to get the parts you need. And when you're done, you check that. Now I need to select a fraction from this strip that represents a length of 2/3. So that's 1/3, 2/3. Now I'll put in my labels, and it says that she has completed 2/3. So the red 2/3 is miles completed, and the purple is the miles remaining. I know that she's done 12, and she's completed 2/3, but I don't know how many miles 2/3 is. And so now I can calculate that out. So I know, thinking back to my multiplicative relationship, that I have 3 groups. Each size of my group has to be 4, because 4 times 3 is 12. So 2/3 of the trip would be 4 and 4, or 8 total. So that's the fraction one. Another use is you can go to Greg Tang's word problem generator. It's an excellent resource where you can generate all kinds of word problems, additive or multiplicative, for all 24 types. You can focus in on one type, or you can do random types, but it's just a really great resource where you can get word problems that I think are easier for kids to understand, language based, that highlight the different types. So here is what it looks like when you go there. You choose what you want. I always choose lists, so you get 10 and you generate it. If you're in the classroom, you could print it and then have a worksheet for them. For right now, we can't, but you have them where you can give them a problem to work in classroom, where they have to type in the word problem, show you how to reason through it, and get the equations using the tool. That's just an extra feature that you can use. But why we really have to be doing this at the elementary level is because once our students get to the middle school, they're taking this reasoning tool and understanding that we should have developed at the elementary level and applying it to algebraic thinking. So to the left is an example from our 6th grade program where they're working through what do additive tape diagrams look like versus, which is this one here, sorry, I was pointing at the wrong one, versus multiplicative equal size groups for tape diagrams. They then have to be able to match an equation to a tape diagram. And then moving into 7th grade, they take this understanding and now they have to go through a 2-step equation word problem and generate a tape diagram that represents that. So is it 2 different kinds of parts, or is it the same one kind of part? And that's the different relationships that they work through for 2 steps. So I hope that you found some value in this resource and me explaining how to use it in a variety of ways, and that you'll try it out either in the digital experience that we have for the remainder of the year, or think about saving it for a tool that you can use as we come back to our classrooms. Take care.